Hello, we are from Group 5 and today we'll be presenting our operating system project, which is Library Memory Management Simulator using FIFO and LRU algorithms. Our goal is to help visualize how memory is managed in operating system when space is limited. We use a library analogy. Imagine each memory page as a book and each frame as a desk. When all desks are full and someone requests a new book, one must be removed, just like in an OS. This project was created with three main goals: to simulate memory management using FIFO and also LRU, to help users understand how operating systems replace memory pages when RAM is full, and the last one is to track page faults, which indicate when a requested page or book isn't available in memory. So let's talk about the key concepts. Before we dive into the algorithms, here are some simple definitions that we can go through together. The first one is page, a book requested by a user. Frame, a slot in memory where book is stored. Page fault happens when the book isn't in memory. FIFO is first in first out, which replaces the oldest book in memory. And the last one is LRU, least recently used, which replaces the book that hasn't been accessed in the longest time.
In our simulator, the user needs to provide the number of the book request, the number of book ID as a number, and the number of the memory frame that are available. And finally, the choice of algorithm, FIFO, LRU, or compare both. For the FIFO page placement, let's start with FIFO. FIFO is the simplest memory replacement algorithm. It uses the queue structure. The first book that comes in will be first to be removed, regardless of the whether it's still needed. In our simulator, it's check if the book is already in the memory. If not, it replaces the book at the front of the queue. Then the page fault counter is updated. And finally, the memory frame status is shown. This algorithm is easy to implement but can remove useful pages, leading to more page fault. For the LRU page replacement, now LRU works differently. It tries to be smarter by remembering the recent uses of each book. It checks if the book is in memory. If not, it finds the one that hasn't been used for longest time. It replaces that book update user's time and show the memory state. LIU often perform better than FIFO, but it need extra tracking, which can be complex in the large system.
I'm Tanishri Parni. Now I'll be explaining about the testing phase. So in the testing phase, let's just run the code first. So when we run the code, we'll get this library memory management simulator. So here we have to give our inputs, the book IDs and also the number of frames. So let's keep that one here. So I've given the book IDs. So let's just change the number of frames to 3. So as you can see, for algorithm, we have here FIFO, LRU, and also we have a comparison node to compare both, compare FIFO and LRU. So what we are doing here is we are testing multiple scenarios to see how many page faults would occur and how the frame content changed step by step. So let's just test FIFO first. So when you run the FIFO, you can see the output here, and below here you can see the total page fault here is 7. So this is for FIFO. So let's just clear the output and we'll move on to the LRU. So run simulation. This is the output for LRU, and you can see the total page fault here is 6. So as you can see, the previous for FIFO it was 7, for the LRU it's 6. So if you want to compare, we just go for compare both and we'll run the simulation again, and then we can see we have the comparison. So the first one is V4. We can see the total page 4 is 7, and down here we can see total page for LRU. Page 4 is for LRU, which is 6. So this is the comparison. So what we can see here is the FIFO showed more page faults. That's because it doesn't consider whether a page is still being used. It just removes the older one. But for LRU, here, LRU had fewer page faults in most cases, especially when some pages were reused. So that's the comparison for both. As you can see here, 7 for and LRU is 6. So the stimulator also shows every step. So as you can see here, first it shows the book ID, book ID that were being requested, and it also shows whether the page is it is caused fault or not. And the third is it shows the memory frames. It shows that current memory status after each request. So moving on, talking about the interface, here the GUI was built using Python and also the Tkinter. It's user friendly. The user can input the data here very easily, and the output also is shown very clearly here. As you can see, it's very clear. We can see the book ID, we can see it's a fault or not, we can see the memory status, and we can see the comparison here clear as well. So there is also a option here, we can see here, it's clear output. So you just have to, after every output here, you just can clear output.
We are proud of our current system, but here are some ideas for future improvement. Add some optimal page replacement algorithm for benchmarking. Create a visual animation of memory frame updates. Let user upload files with multiple book requests. Convert the project into a web app using HTML so it's more accessible. For challenges, we also face some technical and logical challenges. For example, making sure the algorithm behave like real OS system, designing a responsive GUI that can handle errors properly, and also debugging logic errors, especially in the LUR implementation. But through this, we learn a lot about how memory works in operating system and how to translate theory into working simulation. So, in conclusion, FIFO is easier but less accurate. LRU is more intelligent but needs more effort to implement. The right choice depends on the system needs. Our library simulator project allow us to apply theoretical concept in a practical, visual way and make understanding memory management much easier. That's all from me. Thank you.